Hello everyone, my name is Ramadhani and today we are going to discuss about present tense, a relationship as a subset. Welcome to the wonderful world of a relation as a subset. Okay, today we will discuss about relation as a subset, examples and application. First, what is your understanding of the word relation? Relation is the way in two or more concepts, objects, or people are connected, a thing's effect on or relevance to another. Relation is also an aspect or quality, such as resemblance, that connect two or more things or parts as being or belonging or working together or as being of the same kind. What is relation in math? In math, a relation defines the relationship between a set of values of ordered pairs. The set of elements in the first set are called domain, which is related to the set of the element in another set, which is called ring. It is a subset of the Cartesian product, or simply a bunch of points, or ordered pairs. In other words, the relation between the two sets is defined as the collection of the ordered pair, in which the ordered pair is formed by the object from its set. For example, set A is equal to -2 and 1, 4 and 3, 7 and -3, usually written in the set notation form with curly brackets. How about the word subset? A subset, as the name suggests, is a subcollection of any set. Let us assume we have two sets, X and Y. Mathematically speaking, X will be a subset of Y if and only if all the elements of X are present in Y. We can also say that X is contained in Y. This relationship is called inclusion or containment of X in Y. A subset can be classified as follows. First is proper subset and second is improper subset. Let's solve some examples of a subset. Determine whether A is a subset of B in the following. Number 1. Set A is equal to set of all even numbers, and set B is equal to set of whole numbers. Number 2. Set A is equal to 1, 2, 3, and set B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Number 3. Set A is equal to all writing equipment at a stationery shop, and set B is equal to pens. Number 4. Set A is equal to sedan, and set B is equal to all cars. So, as a solution, number 1, the set of even number is given as set A is equal to 0, 2, 4, 6, and so on. Similarly, the set of whole number is given as set B is equal to 0, 1, 2, 3, and so on. It is quite clear that the element of A belong to set B, so A is a subset of B. Number 2. It is clear from analysis the two sets A and B that A's elements belong to set B, so A is a subset of B. Number 3. Set A includes pens, pencils, notepads, markers, etc., whereas set B only includes pens. So we cannot say that all A's elements are in B, which is a condition for A to be a subset of B. In this case, B is a subset of A, but A is not a subset of B. Okay, for number 4, set B includes all types of cars, sedans, hatchbacks, pickup trucks, etc. And A is a set of sedans. So, all elements of A are included in B. Therefore, A is a subset of B. So, let's go to our main topic. What is a relation as a subset? Relation as a subset is partial collection of the set of all possible ordered pairs. For example, set A is equal to 1 and 2 and set B is equal to 3 and 4. So, basically a relation as a subset is the set of all possible ordered pairs. It is also a specific subset of a Cartesian product. For example, set A is equal to 1 and 2 and set B is equal to 3 and 4. If you combine them together, A and B is equal to 1 and 3, 1 and 4, 2 and 3, and 2 and 4. So, what we do here is we distribute the numbers in set A to set B. For example, let set A is equal to 2, 3, and 4, and set B is equal to 6, 8, and 10, and define our relation R from A to B as follows. For all X and Y is an element A and B. Here's the condition. X and Y is an element R means that Y over X is an integer. Here's the question. Is 4 related to 6? Is 4 related to 8? Is 3 and 8 an element of R? Is 2 and 10 an element of R? Letter B. Write R as a set of ordered pairs. Letter C. Write the domain and codomain of R. Letter D. Draw an arrow diagram for R. So, here, how we are going to answer it? Okay, first, write set of ordered pairs of A and B, and then we are going to combine set A and set B in a distributive manner. So, A and B is equals to 2 and 6, 2 and 8, 2 and 8, 2 and 10, 2 and 10, then 3, 3 and 6, 3 and 6, 3 and 8, 3 and 8, 3 and 10, and then 4 and 6, 4 and 6, 4 and 8, 4 and 8, and 4 and 10. After that, we are going to test if 4 related to 6, 4 related to 8, 3 and 8 an element of R, 2 and 10 an element of R. Okay, so here how we are going to answer it. From this, X and Y is an element R means that Y over X is an integer. So 4 related to 6, 4 and 6 is not element R because 6 over 4 equals 3 over 2. Is 3 over 2 is not integer. So 4 and 6 is not element R. Next, 4 related to 6, 4 related to 8, 4 related to 8 is the element R because 8 over 4 equals 2. 2 is integer, so 4 and 8 is an element R. Next, 3 and 8 is an element of R. 3 and 8 is not element R because 8 over 3 equals 2.67. 2.67 is not integer because it has a decimal. Okay, so 3 and 8 is not element R. And then 2 and 10 is element R because 10 over 2 equals 5 equals 5 is an integer, so 2 and 10 is an element R. Okay, letter B. Write R as a set of ordered pairs. So just like what we do in A and B, we are just going to replace E and B to R. So R is equals to 2 and 6, 2 and 8, 2 and 10, 3 and 6, 3 and 8, 3 and 10, 4 and 6, 4 and 8, 4 and 10. For letter C, write the domain and codomain of R. So the codomain is 2, 3, and 4, and the codomain is 6, 8, and 10. So basically, 2, 3, and 4 come from set A, and 6, 8, and 10 come from sets B. The last, letter D. Draw an arrow diagram for R. Arrow diagram, here is our X, our domain, and Y, our codomain. So we're just going to connect it. 2 related to 6 with the condition Y over X is an integer. So 6 over 2 equals 3, and 3 is an integer. So let's draw a line. 2 to 6. Okay. Next, 2 and 8. Y over X equals 8 over 2 equals 4, and 4 is an integer, so let's draw a line. Okay. 10 and 2. 10 over 2 equals 5, and 5 is an integer. So let's draw a line to 10. Okay, next, 3 and 6. 6 over 3 equals 2. 2 is an integer, so draw a line. 3 to 6. Next, 3 and 8. 8 over 3 equals 2.67. 2.67 is not integer, so we cannot draw a line. And next, 3 and 10. 10 over 3 equals 3.333. So we cannot draw a line because 3.33 is not integer. Next, 4 and 6. 6 over 4 equals 1.5. 1.5 is also not integer, so we cannot draw a line. 4 and 8. 8 over 4 equals 2. 2 is an integer, so we can draw a line. 4 to 8. White. Plus 4 and 10. 10 over 4 equals 2.5. 2.5 is not integer, so we cannot draw a line.